In this lecture we will see some process that how we are going to pre-process the data before mining it. Okay, we need to filter the data, we need to come up with some essential components and discard the rest. So these are the topics which we are going to cover in this lecture. This total lecture will be divided into two parts. In this first lecture we will cover up to data integration, and in the next lecture we will cover the data reduction technique and the data transformation and data discretization. So let us begin. What we are going to do first, we have to know that why the processing of data is required, right? In one word you can say we want some quality data, right? We want some data with which we can come up with some knowledge, or rather we can come up with some model using some tools. So if the data's quality is not up to the mark, it cannot come up with some knowledge, if it is not informative enough, so we cannot come up with a good model, right? So before going for the modeling purpose, we have to filter the data, or we have to think of the quality of the data. Fine. So what features we are going to focus on, we will see, or rather to define what data quality means, we are going to focus in this area, that whether my data is accurate. Accurate means obviously we will also see whether it is a correct data or not, right? Accurate means whether it is expressing some meaning or whether it is meaningless, or rather say whether the information, we can gain some information from that data or not. Okay. Completeness. Completeness means there may be some data which is incomplete. Okay, say I have got one table, or say from relational database somewhere. There in some of the details in there, the address of the customers are not available. Okay, say there are 4 fields, one is specifying name, another is specifying say age, another say monthly income, and say address. Okay, so in some of the customers details their address is missing, so that data is not complete. Okay, so in some cases, for the fault of data entry operator, or for collecting data from some sources, right, for during the transformation from one form to another form, this kind of losses happens. Within consistency, the data must be consistent. Okay, so consistency means say in some of the data we are maintaining the date of birth of some customer, but in some of the cases we are maintaining the age of the customer, so it is not consistent. Okay, ultimately we want to debug the same thing, still we cannot say this data is consistent, so we have to come to any one of the modified form. Okay, timeliness, you can understand from the name itself whether my data what I am receiving, is it updated or not. I may receive some data which has been updated, but I'm getting some data which was updated previously, and it is not updated, so we need the updated data, because we have nothing to do with the backdated one. Okay, believability. Believability means how much we can trust on the data. Whatever data we are getting, how much we can trust the data, whether that data is authentic or not. Fine, so we have to this is one of the concern as well. Then interpretability, whether we can understand what data we have got. So fine, so we have got some data from where we cannot debug any meaning, we cannot understand what this data set wants to, means what is the meaning of that data set, what we have received. Then that we cannot interpret that data set. So these are the concerns on the, if we have to focus on data quality, we will see all these features whether they are satisfying or not. That is our goal. Fine. So let us see what are the major tasks in data pre-processing. Okay, here I am not describing anything, rather I'm just reading it out. Data cleaning, data integration, data reduction, data transformation and discretization. We are going to learn all these techniques in this lecture, but still you will also learn, you will see some technique as well there, where I am not going to explain in details about those techniques, because we are going to learn the techniques in very detail in the coming lecture series. There will be some topics as well. Okay, so let us see what data cleaning means. So if we have to focus on real world data, you will see that it needs some filtering, right? Or rather it needs some cleaning. There may be some potentially incorrect data. How it can, why it is we are receiving incorrect data, right? So there may be error in data entry. Some data entry operator has entered incorrect data. Fine, possible. Okay, there may be transmission error. Whenever we are sending some data from one place to another via transmission medium, it may get corrupted, it may get changed, right? There may be computer error, right? After processing, there may be there might be any problem in the software, so whatever output we have got, there may be some error in it. So what are the different kinds of incorrect data or dirty data? What are those? Say incomplete. We have learnt already. You can see in the example. Here occupation field is there, but no value is given to the occupation field. This kind of database we have often found it that in some database some tuple is missing its value, right? Some attribute has no value for say particular 1 to 2 records, or say one field is there named occupation but they have not entered any value. So you can say it is incomplete since they have kept occupation as one of the field, so it had some meaning, but why they have not entered the data there? That is called missing data. Okay, now see noisy. Noisy means it consists of some data which is erroneous, or outliers. Outliers means the model which we are working with, the data set which we are working with, this is a kind of data which is far which can be distinguished from this set very easily, because you can see here salary is -10. Is it any meaningful value? Salary can never be a negative value. Okay, so this is such a value, -10 is such a value which can never belong to the salary set. Okay, so we are telling it as, or we are marking this as outlier, or you may say it is a noise or error, whatever you say. Inconsistent, and the example which I was giving, you can see here in few of the cases they are maintaining the age of the persons, in few of the cases they are writing birthday of that person. So they want to means here they want to mean the same thing, that ultimately what we are considering the age of the person, right? So why we collect the date of birth of a person? To calculate what is the age of his or her in today's date. So in some places they are writing directly the age after calculation, in some places they are writing the birthday, so it is not consistent, right? Say in somewhere they used the rating scale as 1 to 3, in somewhere they have rated it as ABC. Okay, we can come up with the meaning, fine. Rating 1, we can assume like this, rating 1 is equivalent to rating A rating, but is it possible for a computer to predict without any programming? Right, so these are the problematic situations which we come when we have to collect data from different data sources. Okay, say sometimes the the error in the data set, sometimes it may be intentional as well. Okay, someone has put January 1st as everyone's birthday. Okay, it is not possible actually. Say we are maintaining one database, we have incorporated the date of birth there, but after that we have not collected the details from the user, and just to complete my job I have just initialized the value of those fields with some arbitrary value, and it is same for all. Okay, so I have intentionally made the mistake. So this kind of data we also come across. So if we have to say what incomplete data means, how incomplete data or missing data can come. Okay, so data is not always available. There may be some situations where the data is not available. Okay, say we have collected some customers income a few months back, we have documented something. So we have sold some product to a customer following EMI scheme. So we have collected some documents supporting his whatever salary he or she is getting. Okay. But we have not considered that what is the customer's income to be an important attribute at that time while we were designing a database for sales. Okay, we were just focusing on how much sale the company has made. We were just we just tried to represent that. Okay, just try to build a report on how many what is the selling value, or rather how much profit my company has made on this product. Okay, but in that case we are not keeping customer income there. But whenever say I have for other purpose, when I am visiting this database. Okay, at that time I thought that okay, customer income is required. Say we want to we are opening one new branch. There we want to give credit card to the customer, right? So to offer a credit card to the customer, we should be aware of what income, monthly income that person is having. So in that kind of situation, customer income becomes an important part. But previously I thought this is not required for now. So in sometimes data are also not available. Okay, and missing data can be for this kind of situations also leads to the missing of data. It is equipment malfunction, inconsistent with other recorded data and thus deleted. Okay, say we are trying to map one database to the other. Okay, and we followed some normalization concept. So at that time, since it the record that means some particular fields are not matching in are not consistent to the other database, right? So we thought of deleting it. So say during the comparison time, or when we tried to compare this database with the other database, and at that time one particular feature may not had so much importance and it got deleted. Okay, data not entered due to misunderstanding. It is a fault of database operator. Okay, so he or she has discarded and thought that okay, may not keep this data or during the data collection no such data were collected actually, but after that some situation arises when it seems like that okay, this data is essential as well. The certain data may not be considered important at the time of entry, not register history or changes of the data. Okay, missing data may need to be inferred. So this is our job ultimately. What we have to do, if some data are missing, we have to come up with some techniques with which we can infer what can be the missing data. Okay, first choice is ignore the tuple. Okay, usually done when class label is missing. Okay, you will not understand what class label is now, but whenever we will learn classification algorithms in our supervised learning techniques, there we will learn what class labeling is. Okay, and say we got some data with some missing values, and just for now just say we are having some labels, say class A, class B, class C. Okay, 3 labeling. So this data with missing values is not, there are some missing values but some values are available as well. So by using those available values, we are trying to map with this newly encountered data with the labels available. So we found that it is varying considerably, right? So we cannot even after getting the missing data, we cannot label that data to any of the classes available. So we'll just discard those data. But remember one thing, this is not the solution actually. If this kind of missing data is the number is huge, so are we going to discard all of them? So it will have no meaning. Okay, now another approach can be a global constant, example unknown to a new class. We are generating a new class kind of thing, or we are generating a new label and we are just putting those missing data or the data with some missing values to that class. Okay, sometimes we may find the attribute mean and try to guess what can be the value of the missing data. Okay, it's a smarter approach, fine. But rather than all the techniques what I was talking of, the more better technique available, okay, one is Bayesian formula, another is decision tree. But for now we will leave it. We are going to learn this whenever we will move to the classification algorithm part. There we will learn these techniques in detail. Okay, next is noisy data. Okay, noisy data is what? Noise is what? Random error or variance in a measured variable. Okay, and what are the causes of getting a noisy data? Noisy data means erroneous data. Data with error means random error or variance in a measured variable. Okay, and it may be due to faulty data collection instruments, data entry problems, data transmission problems, technology limitation, inconsistency in naming convention. Okay, as we have seen already in somewhere. In some database say they are maintaining age as one of the attribute, in some other they are maintaining date of birth as an attribute. So there the inconsistency lies. So here ultimately what will happen, they will treat them as the two different attributes, and inconsistency will means it will occur, and ultimately we will get noisy data. Okay. Other problems are duplicate records, incomplete data, inconsistent data. In these three situations we also need data cleaning as well. Okay, now how to handle this noisy data? Okay, firstly we are having one process named binning, but we are not going to learn this process in details. Rather we will try to focus on regression clustering, these two features, but still we will learn the regression process in details in classification algorithm and clustering in unsupervised learning process. Okay, but for now we will see a very smaller introduction to regression as well. Okay, but what binning does, if you are interested, you may go through the ebooks that I have shared, and or in study materials you will get some just introductory portion of binning as well. Here what actually we do, we just sort the data. First we will sort the data and we'll partition them into equal frequencies. Okay, means equal divisions. Fine. Now we can smooth by bin means, smooth by bin median, smooth by bin boundaries. So you can understand from the definition itself, we will sort the data, partition them into equal intervals. Then we may find the mean of the, say in there are total 9 data values available. So we have divided into 3 portions, 3, 3, 3. So for the first 3 we will find out the mean and replace the 3 with the mean values, or we will find a median of these 3, or rather we will try to say for this there will be one lower boundary, there will be one upper boundary. So the value which is lying closer to the lower boundary we will map them to the lower one, and if it is closer to the upper boundary we will try to map them to the upper one. So with this what we can do, we can correct the erroneous data because we are focusing on the mean or median, this kind of some statistical tool, because that can normalize my data, or rather they can minimize the error from my data. Okay, now regression is a very useful technique. We will see in some in this lecture as well, a very basic introduction to regression. Then clustering is one of the technique. Just for now, understand this much, that clustering is a technique to group the total data set into different groups. There may be some data which is not fitting to any one of the group. There are various algorithms that how to place one data to a particular group, that we will learn when we will learn unsupervised learning. Fine, but you will find some data which is not actually fitting to any one of the group, or which is lying very further from any of the clusters available, any of the groups available. So you can discard those data and can treat those data as a noisy data. Okay, now another process is combined human and computer inspection. We can just put human effort to correct it, but for huge data set it is nearly impossible. Okay, now data discrepancy detection. Okay, how we are going to come up with some conclusion that this data is having discrepancy, right? We are going to use metadata. What is metadata? It is knowledge about the data itself. Okay, so if we know about the domain, range, or dependency distribution, all these things about any data set, we can understand, we can find out what are the discrepancies available. Okay, there may be check field overloading. What is check field overloading? Field overloading is another error source that typically results when developers squeeze new attribute definitions into unused portion of already defined attributes. Okay, check field overloading means for particular field we always define the size of those field. Okay, now there may be some case, say for a particular attribute or particular field 32 bits is being allotted, but it is using 31 out of them, so one bit is left blank. Now some of the developers did what? They tried to use that one available bit to introduce new attribute definition. So that ultimately results in data discrepancy. So if we check this field overloading concept, we can come up with this error. Okay. Then check uniqueness rule, consecutive rule, and null rule. 3 rules are there. What is a unique rule? Each value of the given attribute must be different from all other values of that attribute. Okay, for if say there may not be the situation always works with this, because say we are concentrating on name field, so 2 persons may be there with the same name, but this is one of the technique to find out the discrepancy. Say it will work very efficiently for those values who are having unique, say PAN number. Okay, so if we can find out, we can apply this concept on such a field where the uniqueness is guaranteed, there we will get a good result. Okay, if we find out any 2 fields having same PAN number, that means that undoubtedly that is having discrepancies. Okay. Then consecutive rule, it says that there can be no missing values between the lowest and highest value of the attribute. Okay, so we can find out like this. And a null rule specifies the use of blanks, question marks, special characters, or any other strings that may indicate null condition, and how such values should be handled. Okay, null means so whenever this kind of special symbols come, and we can put that value. So where a value for a given attribute is not available, if this kind of symbols can be used, so are there. Okay, and we can say that okay, this special symbols are present, so this is a data with discrepancy. Say in place of date of birth, one question mark is present, so you can easily say that the data is not correct. Now this is data discrepancy detection, and now we will how to handle this one. There are some commercial tools available. One is called data scrubbing. We will use simple domain knowledge, the example postal code, spell check to correct errors and make correction. We are doing nothing, but we are just try to correct. Data scrubbing means we are just try to remove the dart from the data and to correct it off. Okay. So you can say here there are some data where the spellings mistakes are there, so we can correct it using spell check. Somewhere say only the postal code is written, so we can try to find out the address from the postal code. So these are the type of data scrubbing techniques available. Now data auditing, it can be done by analyzing the data to discover rules and relationships to detect violators. Okay, here correlation and clustering to find out the outliers. These are the available techniques, that is correlation and clustering, but again we are going to learn this whenever we have learned a little bit of correlation, but we will see it, and we have introduced what correlation is, and we will learn the details of the clustering in our later lecture series. Okay, then data migration and integration. Okay, there are data migration tools available, and some tools are there called ETL, but here in this lecture series or in our syllabus we are not going to learn about this ETL and other things in details. Still, if you are interested, you may go through the ebooks shared or the study materials that I have uploaded. Okay, now the last one, that is data integration. We will see how to integrate data. You can see here data integration means when we try to combine data from multiple sources into a particular source. Okay, you can see here in some of the database, say they are maintaining customer ID in some of the database, say in database A or in say table A to be more precise. Customer ID is being used and in table B customer number is used. So is it possible to map this to, because we can understand, human can understand, okay, they have used the customer ID in place of customer number, but is it possible using any tool to compare these two? No, before that we have to map them to any one name. So this is one schema integration problem. Okay, then entity identification problem. You can see here, if the situation is like this, Bill Clinton is equals to William Clinton. Okay, and in some of the tables, in some of the database they have used this Bill Clinton, somewhere they have used William Clinton. So it is not possible to identify these two persons as same, but if human knows that Bill Clinton and William Clinton is the same person, so they can map it, but for the machine to work on, this is a problem as well. Detecting and resolving data value conflicts. For the same real world entity, attributes values differ from sources are different, and possible reasons, different representations, different scales. Okay, say we are from one area, we have collected some data, they are maintaining the temperature in degree Celsius scale, somewhere they are using Fahrenheit scale. So this is one this can be one means the situation is such that we cannot map these two at a time. Okay, we have to convert any one of them to any one of the standard form. So these are the problems in data integration. Now handling redundancy in data integration. So redundant data may occur when we are collecting the data from different sources and we are accumulating at one place. One problem can be object identification. One object can have different name in different areas, as we have seen the situation like customer name and customer ID. Okay, say in somewhere we are using first name, we are using middle name, and we are using surname. Okay, but in other place we are using name, and instead of first name we are using say name only, and instead of surname we are using last name. So these attribute names are not matching, but they are holding the same kind of data. Okay, derivable data. Okay, one attribute may be derived attribute in another table. Say in one table we are just getting say age as a value present. In other table only date of birth is mentioned. We have to come up with the age of the person by using the current date. So in one place it is a derived, but in other place it is the original attributes. These are the problems may occur. And these redundant attributes may be able to be detected by correlation analysis and covariance analysis. We are going to learn these two topics in details. Just see this one. Correlation analysis, it works on nominal data, and it is just we will see the tool available. We will see one statistical tool available that is called chi-square test, and there we can detect the correlation between the available values. Okay, and just for now, just see the formula, and just we will focus on the last line, that we have to find out the degrees of freedom. And degrees of freedom means this one. R denotes row number of rows available in the table, and C denotes number of columns in the table. So without focusing more on this theoretical approach, we will directly move to the example. Okay, here you can see that here we will focus on two kind of variables, or okay, two kind of variables means we will see some actual outcome and we will see some expected outcome. Okay, actual outcome are those which are written in as a cell values in the table, and expected outcomes are written within braces. Okay, so we are given with the only the actual outcome. We have to calculate the expected outcome. So how the expected outcome is calculated? You can see here the formula: count of A equals to AI and count of B equals to BJ by N. Okay, so here what we are going to do, for the first value we will just multiply this two, means for A equals to AI means that is 250, fine, and B equals to BJ. Okay, so we have to find out what is B equals to BJ. Sorry, we have to find out the summation value. So A equals to AI will be here the summation of 2, that is 300, and that is B equals to BJ will be 450. Okay, by total outcome means what is the value of N here, that is 150. So if we consider like this, we can find out 90. Right, for other cases we can calculate the value in the same process. So if you want to go to the details of the total working out of this EIJ value, you may follow the associated study material which I am sharing. For the first value, just what will be the value for AI? It will be 300, and for BJ it will be 450. Okay, and because this is the corresponding sum row and sum column according to 250, and the total outcome is 1500. So 450 into 300 by 1500 will be 90, right? And that has been written as the expected value. Similarly, you may, for this not play chase versus like science fiction, it will be like 450 into 1200 divided by 1500. Okay, so in this fashion we have to calculate the expected values. Now, since we have got the expected values, if you remember the chi-square formula, it was like original minus expected whole square divided by expected, and for 4 cells we have to calculate it. Okay, so we have calculated the same value for the total 4 cells available, and it is coming to 507.93. Now you can see for this 2 cross 2 table we have to calculate the degree of freedom. So if you remember, there were 2 rows and there were 2 columns, so degree of freedom will be 2 minus 1 into 2 minus 1, that is 1. Okay, so for 1 degree of freedom we have chi-square table. In statistics books you can find out chi-square table. There you will find for 1 degree of freedom chi-square value needed to reject the hypothesis at 0.001 significance level. Okay, so if this hypothesis rejection is taken, then the significance, if it has to reject this chi-square value at 0.001 significance level, it should be 10.828. so you can see our value is much more than this. Okay, and there is one mistake in a slide. Instead of 2 in the in third line, it will be chi-square. Okay, there are some typos here. Fine. So if the rejection is for 0.001 significance level, the value should be 10.828, but our value is higher than that. Okay. So here what we can do, our computed value is above this, so we can reject the hypothesis that play chase and preferred reading are independent. Okay, we can reject this hypothesis and conclude that the two attributes are strongly correlated for the given group of people. That means the correlation is very higher. Okay, so you can see here, since the correlation is very higher, these two data are highly correlated to each other, so we cannot say that these are two independent events. These two events are very attached to one another. Okay, and so the larger the value of chi-square, the more likely the variables are related to one another. Okay, so what we are gaining from this test, this chi-square statistic test, actually it tests the hypothesis that A and B are independent event, or is there any correlation between them, whether these two events are independent or they are correlated to one another. So with the help of this statistical tool, we can find out whether these two attributes or these two data are related to one another or not. Okay, so if the chi-square value is higher, in that case we will say they are correlated to one another, they are not independent. Okay, one more topic, and this is correlation coefficient. It is also called Pearson's product moment coefficient. For this, the previous technique was applied on nominal data, and it will be used for numeric data. Okay, so we will find out the correlation coefficient for different variables, but we are not going to means we'll just pick up very small example, and we will try to see that how this can be useful. Fine. So if you want to go with many broader example, you can see the study material as well. This is the formula for correlation coefficient, and the every symbols has its meaning. It is written there only. Okay, you can see that A bar means the mean of A, B bar means the mean of B values, sigma of A, sigma of B are the standard deviations, and so on. Now you can see if this value results in any positive value, okay, they are strongly correlated, the correlation is stronger. If it is 0, they are independent. If it is lesser to 0, then they are negatively correlated. Okay, so just we will try to see an example. This is the same thing, just we are trying to depict this value as a linear function, okay, as a linear model. You can see here another way of representing this covariance between A and B, that is called the expected values. Okay, how we are finding it out, you can see the same thing what we were using it. So if we have to find out the correlation coefficient, firstly we have to find out the covariance of AB using the formula available, and we have to divide them with the standard variance of A multiplied by standard variance of B. So we will just try to see a very small example here. You can see here, if the covariance of A comma B is greater than 0, then A and B both tend to be larger than their expected value. That means here if A increases more with respect to what the expected value of A is. If it increases more, B is going to follow the same path as well. If it is negative, the covariance value is negative, then if A is larger than its expected value, B will work in a reverse fashion. It will be smaller than the expected value. Okay, so for positive, if A increases from its original level, from its expected value, B will also follow the same path. But if it is negative, if A is increasing more than its expected value, B will follow the reverse path. And independence means that they are not dependent on each other. Okay, so for covariance, for some pairs the covariance may be 0, but it may not follow for all other variables as well. So this is a very smaller example. You can see here some values are given for A and B: 2, 5, 3, 8, 5, 10, 4, 11, 6, 14. These are the values. So we are finding out the expected value of A. Just follow the formula what we have learned so far. You can see here we have added up the A's value, that is 2, 3, 5, 4 and 6, and total number of data values are 5. So that is the mean of A, that is 4, and similarly we have found out the mean of B. Now covariance means what we are going to do, we are going to multiply each A's corresponding value to that of B's value, and ultimately we are going to subtract the mean values or expected values of both of them from the original value. You will find out, you may, if you again consult the previous slides, or rather here we have simplified the formula. It has been written here, that is covariance of AB equals to expected of A dot B minus A bar dot B bar, that is the mean of A and mean of B. So it has been simplified in this manner. So if you find out that, you can see here the covariance between A and B are greater than 0. That means if A follows the path that it will always be larger than the whatever the values of A is, B will follow the same path. So they are strong. The bonding between A and B are the covariance between A and B are positive. Okay, so these are the tools using which we can find out the redundancy in data integration. Okay, so this much for today's class, and in the later lecture we will learn data reduction technique and data transformation and data discretization technique. Thank you.